Okay, all right. First off, let's look at the calendar and let's set the date for the midterm exam, and I'll talk about what's on it. The midterm exam, of course, it's a little bit after the midterm, but right there. First off, Chrome. Actually, probably easier to as soon as my timetable comes up. Okay, so it looks like the midterm exam will be Thursday, November 12th. So, because next week, if I look at the calendar, next week is Dipavali on Tuesday, even though my calendar shows that I have classes that day. Evidently, their timetable doesn't reflect that. That's why yesterday I was trying to schedule another exam for one of my other courses tomorrow, or for next Tuesday, and they reminded me very nicely that I could not do that. So, okay. Now, let's talk about what's going to be on the midterm. That there. And I'm going to use as a guide for the midterm the final exam I gave last semester for the digital course. That there. And I will cover everything up to the start of flip-flops. That there. So, as we look at those topic areas there, we can probably assume off the top of the bat, right off the top, that there will be. Let me take this off just right on the screen here. I need the keyboard. This right here. Right here. Right there. Okay. Right here, since I'm just going to be writing today. So, we're going to start off with number systems. Systems. Right there. So there will be several questions on that. I do not require you not to use calculators. You can use calculators for these questions. That there. I know the person who teaches this course for the BMI, the equivalent for the engineering technology, they don't let them use calculators. But I am perfectly fine with calculators because I have one question on there that your calculator won't do. Right there. So I will expect you to know 1, base 10 to base 2, how to do conversions. 2, I would expect you to be able to go from base 2 back to base 10, right there, and those are straightforward. We did those early on, and your calculator probably can handle that. I keep the numbers down to 8 to 16 bits, so they're not very large, the numbers, so they'll fit onto your calculators if you figure out that they're. 3, I will expect you to know base 16 to base 10, and vice versa. I may as well just show the arrow going both ways, right there, that there. And 4 is base 16 to base 2 and back and forth, right there. So there'll be several, obviously there won't be, it's a 1 hour test or 1 hour, 30-minute test. It won't, not all these are going to be there. And then the mystery question is base question mark to base 10, right there. In other words, I pick a random base. An example of that. Convert 3, 4, 2, base 6 to base 10. That there. So, and remember that what that does is it requires you to remember the definition of a numbering system. That this is 6 squared, this is 6 to the first, this is 6 to the 0. So the answer to this is 3 times 36 plus 4 times 6 plus 2, right there. So when I say base question mark to base 10, that there, it just means I pick a random base. That there, and what I'm looking for is you remember the definition of a numbering system, right there. So there. Another question that I asked, I don't know if I'll ask that there, is that why base 2 and why base 16? Why do we use those two bases right there? And I can tell you real quick the answer. We use base 2 because transistors have only 2 states, on and off. That's why we use base 2. We use base 16 because it's very easy to convert from base 2 to base 16 because you just look at groups of 4 numbers right there. So, right there. Let me go back and let me now look at questions I've asked in the past. As I said, today is going to be relatively short because I'm just giving you a list of problems. I'm expecting you to go through your notes, and then Thursday we'll pick up. Really what I'm going to do on Thursday is I'm going to take a deviation from the course outline, and I'm going to spend about a class or 2 talking about introduction to VHDL. That there. We started on flip-flops last time, that there, and we went through the D flip-flop, went through all the flip-flops out there. We had not started counters yet. Is that the case? We have not done any counters yet. So I'm going to take a little deviation. I want to cover a little bit of VHDL first, and then we'll come back to counters right there. So give me just a second here to find. And again, I'm cheating here a little bit because I am looking at the final exam that I just got done grading for the transfer degree students. That there, and the reason I'm looking at this particular final is because I'll use that as the basis for your finals, but at there. So give me a second here to look at that there. I want to see what questions I ask because I'll probably use similar questions there. Oh, that's wrong one. We don't want the mic. I did the same thing in another class. I brought up the digital final exam, and I started giving questions of the digital final instead of the microprocessor final. So I'm giving all the midterms exams next week in all the classes. So the result, which means I'm going to be very busy next weekend grading midterms out there. And midterms are worthless if I don't get them graded back to you. Okay. The final exam last time up there. Okay, another question that I asked last time, I'll just go ahead and put it down here, is to define the TTL levels. And when I mean TTL levels, I mean you go 5 volts, 3 volts, 0.7 volts, and 0 volts. And this is a low, this is no man's land, and this is a high right there. And whatever levels those are from the notes. I asked what those levels were last time. That there. I asked the difference between a microprocessor and a microcontroller. I did talk a little bit about that, but I don't think I'm going to ask that on the midterm. Out there, so out there. Okay. Binary. Yep. Here, all that I covered. Did I talk about BCD numbers with this group here? Binary coded decimal. Did I discuss that? I think I did discuss that. I'm going to add that here to a list as BCD to base 2, or and let me just spend a second to talk about binary coded decimal in case I didn't. It's a very trivial question and a very easy thing. Binary coded decimal, and right there is 0, 0, 0 all the way to 0, 1, 0, 0, 1. This goes 0 to 9. We don't use A through F. Those are not used. And to convert from binary coded decimal to decimal and back is just the same as doing hex right there. So if you see the number 1001, 10000011, and that is simply 983 in base 10. And if I tell you 236, I want it in BCD, that's 0010, 0011, 0110, right there. You just do it by inspection. So BCD, if I put that on the question, that's an easy one, but that's how you do BCD, right there. So okay, that was question 2 that there on final. Okay, next thing, let me just kind of go back to and continue my list right here. Next thing on my list, I don't remember, I think I'm on number 8 on the list, right there. What, or number 9? Number 9, okay. Number 9 on the list is OR, AND, XOR, NOR, and NAND. Truth tables and symbols. I expect you to know those right there. Right there. Number 10, and obviously there's, I'm listing everything I could possibly put on that there. Number 10 is you're going to get an equation, and you're going to give me a circuit back, right there. So in other words, I'm going to give you A, B naught, C plus A, B naught, and I'm going to say, well, that one actually is going to reduce down, but we'll talk about reducing. I'm just going to say, give me the circuit which would look like this. A, B, C, and then A. And actually, you can cheat and just put the bubble here if you want, right there. You don't have to show the inverter there. And then here's that there. So in other words, I would give you a very simple circuit, and you would give me a simple equation, and you would give me the circuit back. Not there. And the other way is I will give you a circuit that may look like this. I'm just going to draw a random circuit right here. AB, A, B, C, and you know, A, B, C, and you would give me the equation X is equal to A plus B naught ANDed with A plus B plus C naught, for example, right there. So you would go from equation to circuit, right? You know, in this particular case, so I give you a circuit right there. The next thing would be, from either of those, come up with the truth table. Right there. In other words, you're given the circuit, and I'm going to say, give me the truth table for this circuit. And that goes through and analyzes that right there. So I'm giving you all the possible questions that could be showed up there. So, right there. There. And then the next thing is you expect to see a couple of one problem on simplify using Boolean algebra. Algebra right there. We did a number of examples on that. They're there in the slides. And all these are covered out of the slides that they're posted out there. And using the K-map right there. Now in the K-map, I will give you a truth table, and then you're going to put it into the truth table and read out the simplest right there equation out from the truth table right there. Now I can also, on the K-map, I can also specify a sum of products, which is what we've been doing, or a product of sums. Remember, product of sums, we read out the zeros and then we did the De Morgan's theorem twice. So this is a much more difficult problem that there. What I'm going to kind of recommend is that you go through all these, and then if you've got questions on specific ones, Thursday before I get into the lecture, I will answer them up there. So, I'm just listing all the, there's we covered a lot of material up there. There's a lot of material. That's why it's probably best to have a midterm exam at this point, because, this is at least half of the final exam is going to be covered in this test up there. So then when you take the final exam, you've already seen this on the test up there. So you'll see the same questions again with the numbers changed that there. In other words, they're not the exact same questions, but they're going to be the same basic formats. Some of them may be the same questions right there. So the fact is you've seen them before. That makes it a little easier when you do the final exam right there. So again, Boolean, K-mapping, and then I think the last question I am probably would be doing that there, and we really haven't done that. I think that's enough right there. I think we've got enough right here at this point right there. We haven't really talked about decoders too much yet. Let's just 7-segment display decoders and keyboard decoders. We haven't talked about that yet. I think that's everything that would be on the midterm right there. Any questions? You should have a lot of questions come Thursday. That there. I listed all the topics that could be there. But as you look at that there, I had 10, 11, this was 12 right here, and 13, and 14 right here, and really 15. So I have 15 different subjects that I can ask, right? Questions I can ask right there. So, right there. Now, a little bit of a hint right now to let everybody know that, none of you know me very well. I've just started here in January. You've probably heard stories from a few people. I do not write trick questions on exams. I don't think I have to write tricky questions. I don't have to write hard questions. There's a philosophy that I firmly believe is professors do not have to write hard questions. Students will take an easy question and make it into a hard question. If that logic makes sense. My questions will be straightforward. Give me the reason we use binary numbers in digital electronics. Explain why we use hexadecimal instead of base 10 in analyzing truth tables and use it in digital electronics. Minimize simplify the following equation using Boolean algebra. Now, when I say Boolean algebra, I mean I include in that De Morgan's theorem. De Morgan's theorem is part of Boolean algebra rules, right there. Right there. So, give me the truth table for the following circuit, right there. Give me the truth table for the following equation, right there. Draw the circuit for the following equation. The questions are very easy to write, right there. So, they're not long story problems where you have to sit down and analyze them. It's what I'm going to be testing you on is knowing the techniques that have been covered in the first 7-8 weeks of this class, right there. We've got 7 weeks of classes to cover everything in combinational logic with the exception of decoders, right there. We haven't talked about decoders. I'll probably talk about a couple of those. I'll talk about that real quick in this, since we haven't covered. I don't know where they're covered in the book. I've been following the books, the slides, and I haven't seen them covered. But let me just spend a second talking about 7-segment displays. It's not going to be on the test. That's everything on the test. But before I let you go, I just want to make sure I get this subject covered. That there, a 7-segment display. Everybody's seen them, right? And, the LED, you've got 7 LEDs, A, B, C, D, E, F, and G right there. So what a 7-segment display decoder is, it's actually a chip, the 7447, right there. You buy it off the shelf, right there. And what it actually does is it takes a binary number, 4 inputs, and it takes out A through G. Now these are all inverted because the way we typically wire these is we go through a 320 ohm resistor right there, and we have our LCD, or LED, excuse me, right there, and then we connect that to our display decoder driver right there. So this supplies VCC right there, and this supplies either a ground to light the LED or VCC, a high, to turn the LED off right there. So all it is a very simple device right there, and it receives a, the number 000, 001, all the way up to 111. Some of them will do F, A, B, C, D as well, right there. They do D like this right here, and they do B this way. B looks a little bit like a 6, so it's kind of hard to tell that there. So depending on the display driver, but it's not going to be on the quiz, but it's something that you do need to be aware of. That there, if you look at a lot of books, they'll cover how to design the 7-segment display driver. You don't need to design the display driver, because if you pull up Quartus and I gotta put it back in regular mode because when it's in tablet mode, it doesn't give me access to. Tablet mode, turn tablet mode off. Okay. All apps. Quartus. Right there. It's a little bit slow. Right there. And this thing's 7447 right there, and as you can see, there's what it looks like right there. Again, it's a BCD to 7-segment display driver. Here's your inputs, here's your output. If you double click on that there, it won't let me enter it. I thought it might give me the VHDL code for it, but it doesn't. But you don't have to design the 7-segment display decoder driver. It's already built. But what it basically does is each one of these is an output based on A, B, C, D. And what you can do is you go through here, and it's actually, if you look at that particular device, if we do go 0 to 9, for example, and you look at your displays, D, E, F, G, you would have a truth table for each one of these right here to paste that there. So, for example, for 0, A, B, C, D, E, and F would be on, G would be off. So 0, or 0, 0, 0, 0, 0, 0, 1, right there. Because remember, 0 turns it on, right there. 1, the number 1 would be B and C. Everything else is off, right there. 2 would be A, B, G, E, D that would show the number 2 right there. So, and that's all a BCD decoder, this 7-segment display driver is right there. And if you were to look at a 7-segment display, what you would see on the schematic, you would see VCC here, and then you would see your LEDs connected like this right here. this is the schematic you would see right there, A through G over here, right here. And then normally what you would do is you would put it through a quad, or a 7 resistor pack. It looks like a 14-pin LED, or a 14-pin LED, a 14-pin dip IC. It looks like a 14-pin IC. I mean, it's got the legs. There's the part there, the legs there, and from the top, it looks like this. You've got the pins here, right there. It looks just like a normal IC, only instead of having electronics in there, it's just got resistors right there. And it's just basically a 7 resistor pack designed to be used with a 7-segment decoder driver and a 7-segment display right there. And that's how you run your 7-segment. That's how you would get your 7-segment displays right there. I don't know why. I know I did not cover it in this class. It's not on the quiz because it's such a trivial topic in my opinion. It's really trivial. Some books spend 4 or 5 pages talking about it. There's nothing to talk about there. Because all that is in there is that you've got inside here, there's your 4 inputs, and each one of those inputs goes into a black box, and there's your A, and this is just combinational logic in there, right there. And you could take a Karnoff map, and you could simply go through and design each one of those right there. Matter of fact, when I took my professional engineer's exam 20-some years ago, that was one of the questions on the final exam, or on the professional engineer's exam, was design a 7-segment decoder driver right there. Which took a long time, but it was very trivial right there. It was one of those questions that you had an hour for each question. There was an 8-hour exam with 8 questions there, and one of the questions was design a 7-segment decoder driver. Obviously, it took a good hour to do all 7 Karnoff maps and all 7 truth tables. It didn't take quite an hour, but it took a while right there. But it wasn't a difficult problem on this. It was probably the easiest problem on the professional engineer's exam. But it took a long time right there because you had to do 7 K-maps with 4 inputs right there. So that's it for today. That's all that there. My goal today was just to let you know what's going to be on the midterm. It's next Thursday. I was going to have it on Tuesday, but you guys get to stay at home. Now, nobody goes home for dip volley, right? You guys all just stay in the hostel and look at each other. Is that the case? Up there? So, up there. I don't know. Does everybody live in the hostels, or some of you live off campus? I guess that there. But I'm not sure what you guys do on these holidays that are not your religion type holidays up there. So, dip volley is not one that I'm going to do anything with. So I'll probably just sit at home and do nothing out there. So, well, now you got an exam to study for out there. You can spend next Tuesday studying for the midterm out there. It's worth, if I'm not mistaken, probably 20% of your final grade, because I think out there. So it's worth enough to study for, but it's not worth 60% like the final is out there. So, as I recall, the final grade in this class is based on, if I'm not mistaken, it's based on 2 labs at 10% each, and a midterm at 20%. That there. So that there. So I think that's what the final exam, the final grade's based on. I'll have to double check that. I'll let you know Thursday if anybody's worried how many points it's worth. But 20% is actually, you don't want to blow 20%. That's because getting a 0 on that's the equivalent of getting losing a third of the final exam out there. But it's not enough to lose tons of sleep on out there. So to be honest, I've had courses in college where 40% of your final grade was on the midterm and 60% was on the final exam. Nothing else, just the midterm and the final. And then I had one course that your entire grade was based on the final exam. That's way too much pressure to put on a final exam. I think 60% is too much to put on the final exam, in my personal opinion. You know, typically in the U.S., we didn't have any rules that came down from the administration or accrediting agency. We were free to do whatever we wanted. And I treated the final exam like a fourth test. My normal way of grading is that I based all my grades on 20%, 20%, 20%, 20%, 20%. So I had a test in the 4th week that was worth 20%, a test that was in the 8th week that was worth 20%, a test in the 12th week that was worth 20%, and a test in the 16th week that was worth 20%. And then all the labs and homework added up to another 20%. So only 20% was on the final exam, but the final exam was not comprehensive. So, but unfortunately, the Board of Engineers, Malaysia, says that we got to do it this way, so that's the way we have to do it here. So it's just that there. So I'm not necessarily real comfortable with the system as well, but it's what we live with at there. So, are there any questions? Okay, I will get this posted tonight at there because I'm sure that.